All right, so we have the second section of chapter 5 of integers. Again, remember our integers are, we go through here, we're going to talk about multiplication, division of integers in 5.2. Remember, this is again a section that is going to be good for you to go through your e-text also. I'm going to hit a couple things, but in terms of delivery or types of lesson and stuff like that. But these are things you can actually read through a little bit easier as you go through the problems. Trying to keep it in a short video makes it a little tough. Do not forget, when we are dealing with multiplication and division and all that fun stuff, we are talking about integers again. And when we talk about integers, okay, we are talking about remembering numbers like 1, 2, 3, 0, -1, -2, -3. Those are my integers, okay? Those are the things that we want you to make sure you can understand. We're dealing with positive and negatives as we go through this. Now, one of the things with integer models, multiplication, it's what's known as a chip model. All right, so you have three, in this case, the book does a lot better job than I can explaining how to do all this. 3 groups of 2 red chips, okay, which would be a -6, correct? All right, say to find -3 times -2, which equals 6, start with a value of 0 that includes at least 6 red chips, okay? Then remove 6 red chips, okay? So you've got 6 red chips, and then you would zero them out by putting 6 yellow ones. Okay, that gets you to 0. Okay, when you remove the red chips, which you started with, you will have your final answer of +6. Okay, you also have the number line model. Again, read through this. It says demonstrate using the cat moving across the number line. The rules walking the number line, remember, are always start at 0, always face positive or in the right direction. If the number is positive, walk forward. If the number is negative, walk backwards. Okay, so if you go -3 backwards, -3 backwards, that'd give you a -6. Okay, and then you would take the opposite of that, which would be +6. And that's how you use your number line. Okay, and then you also have the pattern. Find 3 times -2. Okay, which would be 3 sets of -2, which is -2, -2, -2, which should be added all up, you get -6. Or you can use a commutative property, okay, which would be -2 and 3 is the same as 3 and -2, which is -6. Or the pattern, which you could do. You notice that you multiply and you keep the sign. So when you multiply -1, -2, you get a +2. -2, -2 would be a +4. So notice two negatives give me a positive, and I just multiply the numbers, so that one should be +6. And you can use that kind of pattern too. Okay. We look at something like this, in which you have A and B are integers. So if A is positive and B is positive, then you just multiply the two and you keep the positive sign. If they're both negative, you're going to multiply the A value and the B value and make them positive with absolute value. Or you're both negative, you end up with a positive answer. If one of your A or B, one of your integers is negative or less than 0, then your answer is going to be negative. And that's one of the things you'll probably learn when you're in school. Okay. Multiplication of integers is closed. In other words, if I multiply 2 integers, you'll always get an integer. Commutative property, it does work. We already showed that. Associative property will also work in multiplication. You also have the identity property, which is 1. Anything times 1 is 1. Distributive property over the addition. Now, some of y'all missed this on the test. For it to be distributive property over addition, there has to be an addition sign. I believe the one on the test had a multiplication right here. That would not be, that would just be straight distributive because, or actually it might have been commutative or associative, one of the two, depending on the problem you got. But because there wasn't a plus sign, it's not distributive over addition or subtraction. You gotta have that plus sign in there. Okay, and then of course in multiplication we have the zero property. Anything times 0 is 0. Okay, multiply anything by -1, you'll get to a positive answer. You'll get a negative. You multiply two negatives, you always get a negative. You multiply a negative to a positive, you're going to get a negative, and two negatives, you get a positive. And then you have distributive property over subtraction, which means you have to have a subtraction sign. All right, so simplify the following. Okay, well, what am I going to do this? Well, we got to distribute this. Okay, so we got to distribute the -3 to the -2. Okay, which is going to give you this. Okay, kind of show you how that works. -3 times this, -3 times -2, and we get what you'll get -3x plus 6. Okay. All right, now this problem. This got some of y'all on the test also, I noticed. When you distribute two binomials, this times this, and this times this, and then this times this, and this times this. Now what they did is they went the opposite direction, which is also the same thing. They went this x times both of these, okay? And then they went the -4 times both of these. You got this, okay? So those it does work two different ways, okay? Either way, you're going to get something that works all the way down. You're going to end up at some point this 2x x squared plus 4x plus -4x plus -16, which ends up these cancel out and gives you x squared minus 16, which we learned back in algebra in high school. You learned this as what's known as the difference of squares formula, okay? Which gives you the integers. If a plus b times a minus b, as long as they both have one positive, one negative, one adding, one subtracting, your answer is going to be the first term squared minus the second term squared, or a squared plus b squared. So if you go back up here, here's the plus, here's the minus, so x and x has to be the same, so that's x squared. 4 and 4 have to be the same, that's 16, and then put a minus sign. Okay? So you can deal these the same way. 4 and 4 would be 16. B and B are the same, one positive, one negative, so I'll get 16 minus b squared. Okay, always have to have a minus sign. It's called difference of squares. Difference means minus. So here we have the same thing. So 4 and 4 would be 16. And we get 16 minus b squared, which ends up being the same answer. Okay. So when using distributive property multiplication over subtraction, always know the reverse possibly might work. Okay. The expressions have to be factored out. Okay, the common factor a has been factored out. Okay, so when we talk about factoring and you have something common, okay, give you another example. If we have 7x minus 5x, what do they have in common? Well, they have an x in common. So if I wanted to factor that out, I can take out the x And then what's left? 7 minus 5. And we know 7 times 5 is 2. So this ends up being 2x. You can do the same thing with this, okay? Where we use it more often than not would be a number like 14x plus 12. Well, if I wanted to factor that, what they have in common, I have a GCF, I have a 2 that's in common. So we factor out the 2, which gives us 7x plus 6, and that's factored out. Okay, and that's the best we can do with that because these do not add or subtract. So, a couple ways that you can look at that. Okay, both the difference of squares formula and the distributive property of multiplication can use factoring. Okay, so they do want you to know how to do a few factoring. So how do I factor difference of squares? Well, how do I know it's difference of squares? Perfect square, perfect square. So I can, since x squared and 3 squared, those perfect squared, I get x and x, 3 and 3, 1 positive, 1 negative. I can do that with difference of squares. Okay, this too is difference of squares, but this is what's being squared, the x plus y, and the z is being squared. So I can, if you see this, whoops, let's go backwards here. So I can write on it again. It's kind of touchy. All right, so this is represented, here it is once, and here it is twice. And then of course you have the two z's, that's its square. Okay, now in this case, notice there's no squares. So all I can take out or factor out is something common. What's the one thing they have in common? The x and the x, only thing they have common. Okay, they may take out an x, I'm not sure. Okay, but if we look at those two values, okay, and then we look at, see what they have, they take out the x, left with a -3 plus 5, and so that's why they have those x's that came out. Okay, so let's erase those before I get to the next page. All right, so then you have some, now division, chip model. Now this one you do have to read because, you know, if I want to divide 15 negatives into 3 groups, that's division, -15 divided by 3, I get 3 even groups of 5. And those are all negative, so the answer has to be -5. Okay. Now these you should know. 12 divided by -4. If I have a positive and negative, we're going to get a negative as our answer, so -3. -12 divided by 4 is also -3. 12 divided by -4, so they're both negative. That's going to give you a positive. And then -12 divided by 5. Okay. So I don't get an integer because 5 does not go in evenly. So it is not defined in the set of integers. You would get a remainder, but we're only talking about integers. So if we're only talking about integers, this would not be possible. Okay, so AB divided by B, as long as B is not 0, is going to be A. AB divided by A, take out the A, should be just B. Now, what happens if you divide by something less than, or deal with if I deal with inequalities? Okay, so when I deal with inequalities, I have to deal with a few different things. Okay, so if I have x is less than y, and I add n to both sides, and n is any integer, no matter what I add, it's going to stay the same, the inequality symbol. Okay, but if I take two things in an inequality and I do a negative to both sides, it actually reverses your inequality. And this is something we learned when we did inequalities. Now, so it does work with integers because we're now dealing with negatives. So if I have two things in an inequality and we multiply by n, which is positive. When I multiply by a positive n, nothing changes the symbol. But if I multiply both sides by a negative or a number less than 0, it's going to flip the symbol. So anytime we multiply or divide by a negative, we flip that symbol. Okay? So using our theorems, how do I solve these kind of problems? All right, so let's just do this by hand. All right, so how do I get x by itself? Well, I have to subtract 3. If I add or subtract, it does not affect the inequality. I'll get x is less than -5. Okay, so how do I solve b? I add 3, which does not change the inequality. And I get -x less than 8. But now I have to divide. Now I have to divide by -1 or multiply by -1, and that's going to change everything to be greater than -8. Okay, and so we deal with that. Right. So to show you again, but in their version, there we go. Add subtract 3 on both sides, doesn't do anything. Add 3 to both sides, get 8, get rid of the negative, that's when that flips the symbol. Okay. Now, if x is less than or equal to a -2, find the values of 5 minus 3x. So I'm plugging in numbers that are less than -2. So once I put in -2 in, okay, that'll give me a 6. So 5 plus 6 is 11. And then you just keep pushing another one in. And that is the end of this session.